Yeah. Hi, friends. So, this is my test analysis of my AWS Flash sale system. Okay, so I will walk you through all the components of my application. So, yeah, let's begin. So, this is my load test.yml file of my artillery package from which I'm going to test it. Okay, so let me show you first my DynamoDB. So, yeah, this is my inventory table. You can see all these products of Apple's, iPhone, AirPods. Yeah, total we have six products, and all the products have 5,000 quantity for now. Currently zero reserved because we have not started our application. And yeah, these are the price of the products. Okay, let's see the orders document. Okay, so now currently we don't have any orders now because we have not started any application, our application. So yeah, once we start, we can start seeing this some orders getting placed. So let me show you our SQSQ. So this is my SQSQ, our order queue. So currently we already have some message, some 207 message here. Means these messages are already placed. So whatever orders will get placed minus 207 will be our actual order amount. Means those amounts will get placed actually. So yeah, this was our SQSQ. Let me show you our Lambda function now. Yeah. So this is our order timeout cleanup Lambda function, which will mark the pending orders, all the pending orders whose created date is greater than 5 minutes. Okay. Because in a flash sale system, we cannot keep pending orders for so long, right? So let me start the logs for this because we are going to start the application. So let me just start the log. So yeah, started. Okay, so let's start our application now. Okay, so now we have Node app. Yeah, Node app, and yeah, our application is running now. So yeah, now let's start our artillery, testing. So we'll test for 30 seconds of duration. Okay, and the request per second will be 500. So 500 requests per second, and the total amount of testing will be 30 seconds. Total duration will be 30 seconds. So let's start our testing. It's artillery run load test.yml. Yeah, started. So yeah, we can see so many things getting printed on our console. So yeah, so let's wait for 30 seconds, or you may just fast forward 30 seconds. Yeah. So yeah, it's completed now. Our application is tested now. So let's see some orders. Yeah, so yeah, logs are getting printed. Let's see the DynamoDB and DynamoDB. Yeah, we have some orders. We're getting so many orders. That's a good thing. Yeah, it's a good thing. Uh, let's check the logs. Yeah, what? Yeah, the logs. Yeah. So in the logs also we can see around 50,000 logs getting printed, getting rejected, orders getting pending, success, getting transaction cancelled, deadlock, conflict. Everything's happening. Yeah, our system is working, and this is the inventory. We refresh it. Yeah, so yeah, we can see some items are getting reserved. Yeah, yeah, that's a good start. We are having good amount of orders. Yeah, so let's see the queue now. Yeah, so we have around 2124 total queue. Oh, so 2124 minus 207 is the actual. So around 1900, 2000 is the amount. Okay, that's a good start, I guess. Maybe as an initial testing, around 2000 orders in 30 seconds. That's a good capture, right? Let's see some messages in our queue. Okay, so yeah, this is yeah. So we are getting order ID are getting stored in our queue. Yeah. So yeah, we will store only the order ID. Okay, so means these orders, whatever stored in our queue, are successful orders and are good for post order processing, means the delivery and all these things we can do all these requirements for these orders. These are successful orders. So yeah, our orders are getting placed. Let's see our lambda function. Yeah. So yeah, lambda function logs are also getting logged. Yeah, this will work parallelly, means it will just mark the pending orders greater than 5 minutes as timed out. So yeah, this is also working. DynamoDB. So yeah, in order in place, everything is working fine. Let's check the performance now. Yeah, let's check the performance. So you can see, means this is the performance of, this is how our application performed. So yeah, you can see 200 success orders, successful requests is 6768, and 500 means the error requests are 8232. Yeah, so you may think that is a poor performance of the application because the 500 errors are greater than 200. But yeah, we have a good reason for that, because in AWS flash sale we have received so many deadlocks, transaction conflicts. Because of transaction conflicts, we will get this 500 errors, because it's a typical scenario in AWS, in the flash sale, sorry, not in AWS, in the flash sale system. It's a typical scenario where the same item is accessed by so many requests, right? So many threads want to access the same item, and the DB cannot, process, give the same request to so many, same item to so many threads. So it will discard the remaining, the other request, right? So that's why the deadlock, the transaction conflict will be there. Because of those conflicts, the 500 request error will come. And it's a typical scenario in any flash sale system. You may also have observed, means whenever you go from, whenever you use any flash sale system, it will mark, it will you may face error, right? So many orders are coming. So that doesn't mean we should avoid it. We should have some retry mechanism, and the same thing I have mentioned in my article, you can check that. And this code access also you can get in my GitHub repo. I have mentioned in my article also, I will mention in this my description also. So yeah, that's it for today. I will keep improving my application, and if we have some suggestions, some discussion want to do, I may be wrong. This application, means this system maybe have some issue. Feel free to correct it. Feel free to raise issue in my GitHub repo. So yeah, thank you very much. Have a great day.